Okay, let's talk about differentiation and integration. Um, MATLAB can calculate an approximate derivative of a function. Again, this is approximating the derivative using really small changes in the function. So what you have to do here is, in this case, we want to find the derivative of the sine function, which is shown here in blue. So we form over the range 0 to 2 pi. So we form a vector x that includes small step size here. The smaller the step size, actually, the more accurate the derivative calculation is going to be. But if you take too small step size, then you're working with large vectors. And then the diff function actually just computes the first difference in the vector, so it's the first element, uh, uh, an element in the vector minus the previous element in the vector. So it's just computes the differences between the elements that make up the vector. Of course, if we take the differences in y, those small differences in y, over these differences in x, the differences in x in each case should be 0.01 when you compute this. So you get the same result actually in this case if you just took diff y and divided by 0.01, because that's what the difference between each element is. Then this dy dx, if we plot that in that's actually in the red plot here, we see a curve that looks like a cosine. That's all. There's a little bit more on the slide here, but that's all I want to talk about here. You don't do this nearly as much as numerical integration. So there are a couple of functions built in for these are definite integrals, so integrating a function from one value of x to over an interval from a starting point to an ending point, or could be x or t in time. Here, one function that's available is the quad function. It uses an adaptive step size. It's really easy to use. You just pass it the function you want to integrate. Again, either as the function name as a string, or you can use the @ notation, or you can use that anonymous function notation and pass either the anonymous function directly or a handle to the function. And then here's the lower limit of integration. Here's the upper limit of integration. And then this will return a numeric result. Really easy to use. There is a trap z function that integrates using the trapezoidal rule. It's a little bit harder to use. It actually takes as one input the vector at which you want to do the trapezoidal point. So here we're integrating from 0 to pi, and then the trapezoids are 0.01 in width. And the smaller you make the step size, the more accurate result you'll get, but the longer it takes. And then the second argument then is the function evaluated at x. So evaluated at those points. So here, if we used, you'd have to pass like my fun of x, or using the shorthand notation, you'd actually type in this whole thing, sine of x times x, like in the dot times x, as in this previous example. And that really should have been dot asterisk x in that slide as well, in order to use the trapezoidal trap z function. So you can try both of these. Again, in my opinion, the quad function's a little bit easier to use. Okay, that's it for this video.